In this video we're going to look at a typical projectiles exam question, and we're going to be using the SAMS question supplied by the WJC in preparation for this new specification. As it's suggested in the specification, some of the questions may ask you to do some derivations, and part A and B do this. Now what I'm going to do is I'm not going to go into much detail with A and B, but I will point you in the direction of the videos in this series that will show you these derivations. So for part A, the displacements in the X and Y, I'm just going to give you those now, but these do come from my video part 5, the equation of the path of the projectile. X is equal to V cos theta times t, and Y is equal to V sine theta t minus a half gt squared. Part B, I would suggest that you look at my video of part 2, and this is for the range of projection of a particle. So if we move straight on to part C, what we're given there is the maximum range of the particle is 392 meters. Correct to one decimal place, find the speed of projection, the time of flight, and the maximum height attained. Now we've been given the maximum range of the particle, and we know that the range equation is given by u squared over g. Well, in this case it's going to be v squared over g, because the initial projection was given as v, times sine 2 theta. Now what's interesting is they state the maximum range in this question. That means the furthest point the projectile could reach. And in this case, you can only get maximum range if you set theta to be 45 degrees. Now in previous videos we've discussed the symmetry of the parabola and the distance achieved. Now if I projected something vertically upwards at 90 degrees to my horizontal, it wouldn't actually travel any distance in the horizontal, it would travel 0 meters in horizontal. If I projected at 0 degrees to horizontal, again it wouldn't travel any distance because it would hit the ground immediately. And then what happens is incrementally the horizontal range will increase as we increase theta, until eventually it reaches its maximum range at 45 degrees and then starts to reduce. So it's a handy thing to know that maximum range is achieved at a projection of theta is 45. That sets sine 2 theta to be 1. Sine 90 is 1. So my range therefore becomes v squared over g. Well, my range is 392, which is v squared over g, or 9.8. And then obviously v will become the square root of 392 times 9.8, and that gives you an answer of 62 meters per second. Now that's part 1. Part 2 asks for the time of flight. So the time of flight is given by the equation 2u sine theta over g, and in this case my u is v, because that's the projecting speed as given in the question. Well, we know what that is now, so that's 62. So now we have all our information there. So time will be 2 times 62 times sine 45 divided by g. So my time is equal to 8.95 seconds. Now in part 3 it asks for the maximum height achieved by the projectile. Now in part A of this question you're asked for the x and y displacements, so we're really interested in the y displacement here. So y equals v sine theta times t minus a half gt squared. Now obviously it's a parabola, everything is symmetrical, we've just discussed this before. So the maximum height will be when the time of the flight is halfway through. So we'll be using a time not of 8.95 but the halfway point of the journey, which is 4.47 seconds. When we substitute this in with all our other values, we can then find our maximum height. So y will equal 62 sine 45 times 4.47 minus a half of 9.8 lots of 4.47 squared. And that gives a maximum height in the y, or the vertical, of 98.1 meters.